Hello, Matthews Gatos here. In this video, I'm going to go over and do all the questions in the practice test to help you guys get prepared for Chapter 4 assignment. So let's go through and look at the questions. No, I'm not going to do it that way. Let's do it this way. Okay. So use the following information to answer the next question. A partial graph of a to the x is shown. Which of the following is a partial graph of 1/3 a to the x? So first of all, this is my base function. And I can see in my base function that it is an increasing graph. So because the base has to be greater than 1 because it's an increasing graph, and it has a y-intercept at 1. Those are all the rules of my base function. So if I want to know which of the following is a partial graph of 1/3 a to the x, the base is still the same. I should expect to see an increasing graph. So I know these ones are not the option. And then I should expect to see an increasing graph with a y-intercept at 1/3. So a smaller y-intercept. So you can see in this base function here, this one here makes the most sense, because if that's a y-intercept of 1, that could be about a y-intercept of 1/3. So C and D are not options that are correct because they're decreasing. A is not an option because it is below the x-axis, and we haven't moved the graph up or down. So I know that that would not be the right answer. Okay, number 2, the range of f of x equals -3 to the exponent of x. Okay, so normally if I just look at my function 3 to the x, I know that y is greater than 0. But because I have this -3, that means I'm flipping the graph over the x-axis. So I have a reflection. So since I have a reflection, I'm going to go from an increasing graph like this. It's going to flip over the x-axis to look like this and be a decreasing graph. So everything is going to be below 0. So this would be my option here. Okay, number 3, the graph that represents y equals a times b to the x, where a is less than 0. So if a is less than 0, that means that I have a reflection in the x-axis. And the base is in between 0 and 1. So the base in between 0 and 1 would be a decreasing graph. So I'm going to look for a decreasing graph that has been reflected in the x-axis. Well, let's think about that. So here's what a decreasing graph would look like. This is just when my base is in between 0 and 1. So if I'm going to take that graph and reflect it, like flip it over the x-axis, it's going to look kind of like that as a very rough sketch. Okay? So looking at that, I can see it's going to go from a decreasing graph to an increasing graph. So the one that matches that, there it is, option D. Okay, the domain of g of x equals a times log base 3 of x. Okay, when we have a log function, we can't take the log of a negative number. So whatever the argument is right here has to be positive. So x has to be greater than 0, but still an element of the reals. So that would be option A. Can't take a log of a negative number. Number 5, the equation of the asymptote. Okay. Logarithms don't cross the y-axis. So when I look at a log graph, now this log graph here has an invisible base of 10. So that's like the common log. So I could rewrite this as 2 log base 10 of x. So since the base is 10, that tells me it's an increasing graph. And so it would look, I don't know, something like that. Okay, with a x-intercept at 1. So if I'm going to take that log graph and I'm going to vertically stretch it, it's not going to affect my asymptote because I do have an asymptote right here at x equal to 0. So vertically stretching is not going to change that. So I still have an asymptote at x equal to 0. Okay, consider the exponential functions. Okay, and partial graphs are shown below, but not in the order above. The graphs are drawn with the same scale. So basically we're matching them. Okay, so let's use what we know about bases. Let's start first of all with the increasing decreasing. Okay, so if I have a base of 3, that's an increasing graph. Base of 1/2, that's a decreasing graph. Base of 2, increasing graph. Base of 3, increasing graph. Okay, so it looks like I have 3 increasing and 1 decreasing. So that makes it easier for g of x. So 1, 3, and 4 are all increasing. This is the only decreasing. So g of x has to be diagram number 2. So g of x is number 2. Okay, now let's go back up here. So these are all increasing graphs. So the only thing that's going to help me determine the difference between all of them is the y-intercept. So this one has a y-intercept of 1/2, y-intercept of 3. Oh, that's the decreasing graph. I mean, you can still know it's 3, but we don't necessarily need it. This has a y-intercept of 3. This has a y-intercept of 2. So I'm going to look at the increasing graph that has the biggest y-intercept right here. That must be the h of x of 3. So diagram number 1 must be h of x. And that's in the 3rd box. Then my next biggest y-intercept is 2. So this one here must be a y-intercept of 2. So that one's 3, this one's 2. This one I would call k of x. So that means that k of x is diagram number 3. And then diagram number 4 would be the smallest y-intercept of 1/2. So this one here is probably a y-intercept of 1/2, which would make that f of x. So that means that f of x is diagram number 4. So I would call that 4, 2, 1, 3. Okay, for this one here, which of the following graphs does not pass through the point 1, 10? Okay, so this is just an x value, this is a y value, so I would just substitute in x and y and see if it works out. So y equals 10 to the x, that's true. Here, y equals 2 times 5 to the x, that's also true. Y equals 4. Oh, I have Bob, oh my goodness, my smartboard ghost. He's visiting me here in my tablet. There we are. Okay, so y equals 4 times 6 to the 1. That's not true. 4 times 6 is not 1. So it has to be option number C. Okay, next one. Graphs 1, 2, 3, and 4. So I have, looking at these, use the following graphs to answer the next 2 equations. So we're looking for a graph that represents the log and a graph that represents an exponential. Well, let's just classify these as exponential or logarithmic. So this one here is exponential because it lives in quadrants 1 and 2. This is an exponential increasing, so I know that my base is greater than 1. This is an exponential decreasing, so I know my base is in between 0 and 1. Okay, so exponential and log graphs are just inverses of one another. So exponential lives in quadrants 1 and 2. Logarithmic lives in quadrants 1 and 4. So I know these are both log graphs, and exponential and log graphs have the same base. So this one here is increasing, so this is a log that's increasing, so my base has to be greater than 1. And this is a log that's decreasing, which is in between 0 and 1. So just so we're okay on why that is increasing, so for me to tell if something's increasing or decreasing, I look as x gets bigger, what is happening to y? And when I talk about x getting bigger, I'm talking in the graph from left to right. So if I start over here and I'm getting x bigger and bigger, you can see y is getting bigger, which is why it's increasing. Left to right, as x gets bigger, you can see y is getting smaller. That's why it's a decreasing graph. Okay. So the graph that represents a log base b of x where a is greater than 0, no reflection, and the base is in between 0 and 1. Well, this is our log graph that was in between a base of 0 and 1, so that's option number 4. Number 8, the graph that represents the exponential where a is greater than 0, no reflection, and the base is in between 0 and 1. Well, these were the exponential, and between 0 and 1 means it's decreasing, so that's graph number 2. So this one here has to be an answer of 2. Okay. Next question. Consider all the exponential functions in the form a times b to the x. The 2 graphs of such functions are shown. If a is greater than 0 in graph A, then the value of b must be, okay, so a greater than 0 means it's not reflected. And the base is, as x gets bigger, from left to right, y gets bigger as well. So it has to be a base greater than 1. Okay, number 10. If the function has a less than 0 and b greater than 1, then the graph of the function f of x. Okay, so now if a is less than 0, that means there's a reflection. and the base is greater than 1. So let's look at when the base is greater than 1. If the base is greater than 1, I have an increasing graph. But because I have this reflection, a less than 0, that means there's a reflection. It's reflected across the the x-axis. So that graph there, you can see that it is a decreasing graph because as x gets bigger, y gets smaller, and it's decreasing from quadrant number 3 to quadrant number 4. So option A would be my answer. Okay, number 11. Graph 2 is a reflection of graph 1 in the y-axis. Students are told that graph 1, A is 2, B is 3. They are asked to comment on A and B for graph 2. Which of the following is correct? Okay, so graph 1, A equals 2, B equals 3. We want to comment on the graph for graph number 2. Okay, so for this one here, let me just read this again. Graph 2 is a reflection of graph in the y-axis. So if I'm reflecting in the y-axis, my x value, or sorry, I'm not reflecting it in the x-axis, so I know A has to stay positive. So if A is positive here, A has to be positive here. Okay, so I know, looking back down at my options, I can get rid of these because if A was negative, it would be reflected across the x-axis, and it's not. It's been reflected on the y-axis. So basically, we have to just decide on the base. Right away, without even looking at the graph, I see what the answer is. You can't ever have a negative base for an exponential or a logarithmic. So because, if we go back up to graph 2, because it is a decreasing graph, I know that my base is in between 0 and 1. So the only option that makes sense is a positive A value and a base in between 0 and 1. Perfect. So C is the answer. Okay, looking at this one here. So consider all log functions of the form a log base b of x, and the two graphs are shown below. Okay, so looking at this, number 12 says, if A is greater than 0 in graph 2, so A is greater than 0, meaning there's been no reflection, the value of B must satisfy which of the following conditions? So as x gets bigger from left to right, you can see that y gets smaller. So this is a decreasing graph, which means my base has to be between 0 and 1. So the option for this that would be correct is B. Okay, the next one. If the function f of x, the values of a and b are both positive, then which of the following x values is the function of x not defined? Okay, so, they're talking about f of x up here. So let me read that again. The values of a and b here are both positive. Which of the following values of x is not defined? Okay, so basically they're asking you, what's the restriction on x? And x is the argument, and the argument has to be a positive number. So the only one that doesn't make sense here, which of the following values of x is the function not defined, is this one right here, because 0 is neither positive or negative. It's actually called a neutral number. So the argument, that's what we're taking the log of, must be greater than 0, but not equal to 0, just greater than 0. Okay, number 14. It says, if graph 2 is a reflection of graph 1 in the x-axis, so if I'm reflecting in the x-axis, okay, that tells me that A is negative, first of all. So I'm reflecting in the x-axis, so I know that A has to be a negative value. Okay, students are told that in graph A equals 5, B equals 2. They are asked to comment on A and B for graph B. So first thing that I need to know is that the A value has to be negative. So right away that takes out student number 2. That's wrong. Okay, which of the following students' responses to graph 2 cannot be true? Oh, okay. So let's see here. If A is, okay, number 2, number 3. So let's go back up and look at the graphs here, okay? So graph 2 is a reflection of graph 1 in the x-axis, yes. So if I take this graph here and I reflect it in the x-axis, it's going to look like this, okay? So this part here comes down, this part here comes up, okay? So this is what my graph is going to look like that, and that's pretty reasonable to what it says right there. Now, if I'm reflecting it, the graph here has to start at for example, a b value. Hold on just a second. Let me just read this here. Oh, there it is. The b value is 2. So if I have this graph here is y equals to 5 log base 2 of x. So this is the original graph. Students are told that the graph 1 is this. They're asked to comment on A and B for graph number 2. Okay, so for graph number 2, I know that A is negative. Y equals to negative 5 log, and then we have to figure out what the base is. So I'm going to say that the base here, if we had a base of 2 here, that would be correct because the base stays the same. I would change the base if it didn't look the same in the graph. So because I'm increasing here and I reflect in the x-axis, I'm decreasing here, which also means that I'm decreasing here. So if I go back down over here, A has to be negative and B is positive. So I'm going to say that student A is correct. They are asked to comment. Which of the following students' responses about graph 2 cannot be true? Okay, well, student 2 can't be true. And yes, so I'm going to say here, student 3 only. So the reason that I say it is student 3 only is because A has to be negative, which is true, and then B has to be a positive, or sorry, a number greater than 1. So this is why student number 3 is wrong. Let's go back to student number 2. They said that A was positive. If A was positive and the base was a half, that means that there would be no reflection, and the base being a half would all of a sudden turn into a decreasing graph. So in terms of matching the graph, they're correct, okay? So if A is positive 5 and base is half, let's go back up to here. So what they're saying is this graph here, graph number 2, can be represented by 2 different equations. We can say that this would be the graph where it's reflected, negative 5 log base 2 of x, or we can say that it would be no reflection, but the base would change to be a half. That would be correct as well. But the one that can't be true is student number 3, because they said there's a reflection and the base is in between 0 and 1, which means I'm decreasing, and then base in between 0 and 1 doesn't fit, because then it would be an increasing after the reflection. So the student A could be correct, although we said that there was a reflection, but student 3 is dead wrong because they're saying that there's a reflection and the base is in between 0 and 1. So student 3 is the only one that can't be true. Okay, looking at number 2. So to the nearest tenth, the x-intercept of the graph. So the x-intercept of any log function is always going to be 1. The only thing that will change that is a left or right movement, and I'm not moving left or right, I'm just vertically stretching it, so that won't change the value. So the x-intercept is 1. You could also put that into your calculator and see the value of that. Okay, a student graphs the following table measured data and suggests that the relationship between two quantities is exponential of the form y equals a times b to the x. Student carries out an exponential regression of the data and determines the equation of this form, which best represents the data. What's the value of b? Okay, so we're going to go to our calculator to do that. So this is a table of values, which I'm going to do a regression on. Okay, so let's go and set our calculator up to be ready. So I'm going to clear everything in my y equals, and I'm going to go up here and turn the plots on. Okay, and then I'm going to clear anything that I have in my lists. So I want to clear all lists. And there we go. So now I'm ready to start entering it in. So I'm going to go Stat, Edit. And then in list number 1, I'm going to enter in my x values, which is 2, 5, 7, 11, and 14. That's my x values. In list 2, I'm going to enter in my y values, which is 0.9, 12, 69, 2,280, and 31,500. There we are. Okay, and then we're just going to do an exponential regression to see what our b value is. So out onto my main screen, I'm going to go Stat, over to Calculate, and I'm going to go down to exponential regression, which is option 0. And I just want to calculate it. So I'm going to go down here just to see what my b value is. And there you can see my b value is 2.39, and the question wants us to round it to the nearest tenth. So we'll go back over here and record it as 2.4. So 2.4. Okay, so b is equal to 2.4. Okay, and number 15. Diagram P is on the partial graph of log of x, so this one here. Point Q could be on the graph of which one? Okay, so this one here, the base is equal to 10 because it's a common log. Common logs have a base of 10. And then this one here, I'm going to look at that. I have to determine which point it could be on the graph. Okay, so first of all, we don't do anything with natural logs, so we're going to take that off. Okay, so we have log base 100, log base 5, or log base 2. So this graph here, you can see it has a bigger base. That I for sure know because it is kind of a steeper graph. So it has the x-intercept at 1 there, but it's been stretched further away from the y-axis. It's more increasing because it's a steeper graph. So I know that whatever my base is, it's going to be greater than 10. So looking at my options, it would be option D. Now, you could put each of these into the calculator and see which one makes sense. Is it a smaller base or is it a bigger base? Okay, and in doing so, you can see that the base is actually bigger. So a potential base would be a base of 100. Okay, so for this one here, part of a fundraising effort for her favorite charity, Shannon has decided she will run from Calgary to Winnipeg. Her strategy is to run 10K on the first day and increase her distance gradually each subsequent day. The chart below shows how far she will run in each of her first 4 days. Okay, so she's going to create an exponential function, and using technology, we're going to find the base b. Then we're going to find what day she runs more than 15K, and then we're going to use her model to find how long she'll run on the 30th day. Okay, so this is a regression question, so I'm going to go back to my calculator and set it all up. So again, I'm going to go in and clear all my lists. So I'll do second plus sign, clear my list. Okay, and then I'll go in stat, edit, and I'll enter my information in. So in list 1, I'm going to put my days, which are just 1, 2, 3, and 4. And then in list 2, there we go. In list 2, I'm going to put in my distances. So 10 kilometers, 10.25. I'm going to do 10.51 and 10.77. Okay, so to do this now, I just want to kind of get an idea of what the graph looks like. So in my Y1, I make sure that my plots are on, and then I'm going to do zoom stat. So zoom stat, again, fits your window setting according to your points. So this is a start for your window setting. So there I can see my 4 points. I'm going to go into my window, and remember, I always want my minimum at 0 for each X and Y, because I want to see what my origin is. Okay. So if I look at this, X is the day number, and just scanning the questions, I'm going up to day 18. So 4.3 on the X scale isn't going to cut it. So let's change that to 20, and we'll go up by 2s. And then Y is my distance, and it says on what day will she run more than 15K? And I'm only going up to 11.9. So let's make this up to 20, up by 2 as well. And there would be my graph. Okay? So let's come up with our regression, which is an exponential. So we're going to go stat, over to calculate, and then I'm going to go all the way down to the bottom of my list, which is option 0. Okay, so X is in list 1, Y is in list 2, and I'm not just going to calculate it this time because I need it for all my other questions. I'm now going to store my equation in Y1, which is just a copy paste. So I'm going to go alpha trace and go into Y1. And then calculate. Okay, so there I've calculated it, so I can see that my base 1.025. Let's just record that right now. 1.025, so I know that B is my option there. And then let's hit graph to see what my graph looks like. There we go, going through the points. Okay, perfect. So using the model, the first day she will run more than 15 kilometers. So 15 is a Y value. This is an example of Y given, X needed. So Y values go in Y equals. So I'm going to put my 15 in there, hit graph. And I want to find this point of intersection. So in my calculate menu, second trace, I'm going to choose option number 5 for intersect. And I'm going to press enter, enter, and enter again. And there we are. We're at 17.38. So 17 and a bit of a day. So because we're talking about number of days, we would round that up. So this would be on day 18. Okay, next question. On Shannon's model, determine the distance to the nearest tenth of a kilometer. She will run on the 30th day. So in my calculator, the day number is an X value. So this is an example of X given, Y needed. Now, I actually don't think I went up high enough. No, I only went up to 20. So let's make this a little bit bigger. We'll say 35 up by 3. Okay, there we go. And we want the 30th day. So I had to adjust my window so that I could actually see the 30th day. So I'm going to hit trace. Now notice you're on your plots. We don't want to trace on a point. We want to trace on our function. So press the down arrow. And now you're on your equation. And I want to know what the distance is on day 30. So I'm going to enter in trace 30. 30 is an X value. And if I press enter, it will tell me the Y value that goes with that. And there it is, 20.5. So go back in here, and that answer will be 20.5. Okay, so we're going to omit number 18. You're not going to see, remember, anything with natural log or E, unless the natural log is for a log regression. Okay, on to number 19. So number 19, we're looking at the number of years, Y, it takes for an investment of 1,000 to increase in value, and it can be modeled by a log function. So this is the table showing Scott's investment period over 10 years. So we're going to be looking for a log regression for this, and I know that because they stated it. Remember, the question will always state if it's exponential or logarithmic. So again, I need to go into my table, and I'm using this for the next 2 questions. So after I come up with my equation, I'm looking for the number of complete years for the investment to double. So my table needs to go up to be able to see $2,000 because I'm starting with 1,000. So 2,000 is an X value. This is an example of X given and Y needed. So we're going to use trace, just kind of looking ahead at the question. And then the value of the investment after 15 years. 15 years is a Y value. So this is an example of Y given and X needed. So I'm going to use my intersect. Okay, so just so we can kind of see what we're going ahead for the question to help us with our windows. So let's go into Y equals, clear everything out. Second plus sign, clear my lists. And now we're ready to go. So go into stat edit, and we're going to enter in all of our X values in Y1. So that will be 1,082 and 1,170, 1,265, 1,369, and 1,480. Okay, then we're going to go over to list 2 and enter in our Y values. So that's 2, 4, 6, 8. Who do we appreciate? 10. Okay, so now that we've done that, let's do a quick zoom stat. So zoom stat, the calculator gives you what it thinks is the best window, and it's a good starting point. But let's go into our windows and do it ourselves. So remember, X and Y min always have to be 0. So that's where I start first, and then I scan my question. So X is the value, and remember in question 19, we're going to look for where it doubles. So we have to go up to 2,000. So let's go just a little bit past 2,000, say 2,500, and I'll go up by 500s. Now, y is the number of years, and we were looking at after 15 years. So we have to include 15 here. So let's say go up to 20 by 2s. Okay, now when I hit graph, there is my graph. So we're going to do a log regression. So let's get out of here. And we're going to go stat, over to calculate, and I'm going to go to natural log regression, this one here. Don't choose this one, that's linear regression. I want natural log regression. So I'm going to calculate it. X is in list 1, Y is in list 2, and we are storing our regression in Y1. So alpha trace Y1. And now we can calculate. Okay, so in this question here, we're using the linear regression. They're not asking us for parts of it. They're just asking us to use it to come up with some different parts. So if I hit graph, there is my equation. Okay, so first question, number 19, says, determine the number of complete years it will take the investment to double in value. That's an X value. So I can do trace 2000. Oops. Now there we go. Let's try that again. If I hit trace, I forgot. I'm on my plots. So I need to press the down arrow. There we go. Now I'm on my equation. And I'm going to hit 20. So trace 20. And that will tell me my answer. Not 20, 2000. Yes, double in value, 2000. Let's try that one more time. 3 times is a charm. No, 4 times is a charm. There we go. So trace, down arrow, so I'm on my equation, 2000. Press enter. There we go. 17.64. So I want the number of complete years, so that will be 18. So we can go over here, and we know that this is 18. Now, next question, the value of the investment after 15 years. So go on to my calculator. The only place you can put y values, again, is in y equals. So go down to y equals, add in 15, and hit graph. Okay, and there's the intersection point right there. So second trace, option number 5, and then just press enter 3 times to come up with the intersection. So the intersection is, the value of the investment will be $1,800.38, but they rounded it to just 1,800. So that would be option number A. Okay, next one here. So the rate of radioactive decay is also often described, the concept of half-life is the time it takes the radioactive to decay to half of its initial amount. So half-life is actually the time it takes to cut in half. So they've given you this formula for cobalt-16. The half-life is 5.2 years, which is why I'm dividing by 5.2. The initial amount of cobalt-60 is 150 grams. That is a y-intercept, which is this value right here. So the initial amount, or the y-intercept, is 150. Then the number of years to the nearest tenth it would take to reduce to 30 grams. So 30 grams is a y value. So this is an example of y given, which is 30, and x needed. Okay, let's put this equation into our calculator. So let's go into our y equals, and we'll clear out everything that we've done. We're not using our plots anymore, so we'll just turn that off. There we go. And let's enter in our equation. So our equation is 150 multiplied by the base of a half, 1/2, and then to the exponent of, and I'm going to put this whole thing in brackets, x divided by 5.2. Okay, now we need to adjust our windows. So x in this question is time. So it's taking 5 years, about 5 years, to cut something in half. And looking ahead to number 6, see how they're asking how much is left after 24 years. So our x value has to cover 24 years. So let's change this to say 30, going up by 3s. Now y is the amount of cobalt. I'm starting with 150 and I'm cutting it in half each time. So I'm just getting smaller. So let's go just above 150, say 200, and we'll say go up by 20s. Okay, now we hit graph. And now you can see it's a decreasing exponential graph. So the first one, question number 5, is saying the initial amount is 150. The number of years it would take to reduce to 30 grams. So back in here, we said for 30 grams, this is an example of y given, x needed. So y values go into y equals. So I'll put in 30 grams here and then hit graph and find the intersection. There it is right there. So I just have to calculate that. So second calc, option number 5, enter, enter, enter. And there it is. It's going to take 12.1 years because they want it to the nearest tenth. So it'll take 12.1 years. So we can record that now. Next one says, to the nearest tenth of a gram, the number of grams remaining from a 250 gram sample after 24 years. So we want to know how much is remaining after 24 years. Okay, so let's just see here. From a 250 gram sample. So we started with a 150 gram sample, and now it's a 250 gram sample. So I'm going to change my equation, instead of being 150 to be 250 times 1/2 to the t over 5.2. That was pretty sneaky. And this is an example of x given 24 and y needed. So we're going to have to adjust our equation and probably our windows as well. So going in here, change this to 250 and then clear that out. And let's just adjust our windows. So it's at 250, so let's just go a little bit higher than 250. Let's say 300. And we'll go up by 50s. Okay, so here's my new graph because my substance has changed. Okay, so I'm starting at 250 and decreasing from there. I want to know at 24 years. So I'm going to go trace 24. So when x has a value of 24 for 24 years, press enter and figure out the y value, which is they want to the nearest tenth, 10.2. So that answer here would be 10.2 grams. So pretty tricky here because they changed this from 150 to 250. So we have to pay attention to that. Okay, last question here is a written response question. So what we have population of a rural community has been decreasing since 2007. The partially completed table below shows the population decrease from 2007 to 2012. Complete the table below. So we have the year number, the population, how much it is decreased by, and we want to know the percentage of the decrease, which is just the decrease out of the starting population. So since I'm decreasing by 280, and I'm decreasing from this amount here, 24,200, I divide the two to get that answer. And then I do, let's change the color, 785 out of the original amount here, and I get 3.37%. And then I'm going to take 795 out of 22,535, and I'm going to do that, and I'm going to get 3.53%. And I just keep going down the table. So 760 out of 21,740, multiply by 100 to get a percent, 3.50. And then 730 out of 20,980, multiplied by 100 to get a percentage, and I get 3.48%. Then it says calculate the average of the percentage of decreases, answer to the nearest tenth of a percent. So that just means take up all of these numbers here, add them up, and average means divide by how many I have, which is 5. So I add all of these up and divide by 5, and when I do that, I get an average of 3.5%. Okay, the relation between year number and population can be written in this form. P of n equals a times b to the n, where P of n is the population n years after January 2007. Use an exponential regression to determine the equation of this relation, rounding to the nearest value of a, or rounding to the nearest hundredth for a and the nearest thousandth for b. Okay, so what we need to do here is put all of this information into our calculator and come up with an exponential regression. Okay, so let's go into our calculator and we're just going to clear everything out, turn on our +1 when we're doing a regression, and then let's go in and clear our list. So second plus line, clear all lists, And we're ready to go. Okay, so let's go into our list. So stat, edit, and in list 1, we're going to put all the years since January 2007. So it's going to be 0, 1, 2, 3, 4, and 5. And in list number 2, I'm going to enter in all of the populations. So 24,200, and then 23,320, 22,535, and 21,740, 20,980, and 20,250. And then just check to make sure you didn't make any mistakes. Okay, so I'm going to go zoom, and then I'm going to go stat, and the calculator will do a window that it thinks is good. Did that work? Okay, so in this one here, I had to turn my plots on. So I went back in here and just made sure my plots were on. And when I did zoom stat, it gives me this window setting, which I know is not a good window setting because I can't see the origin here, but it's a starting point. So let's go into our windows, and we always want to start X and Y at 0. So see Y starting all the way up at like 19,000. Okay, so if we hit graph, okay, there is a better window setting. So I want to come up with the exponential equation for this. So out onto my main screen, and I'm going to go stat, over to calculate, and then down to option 0, which is exponential regression. Okay, so list 1, list 2, and I want to store it in Y1. So alpha trace Y1, and then I can calculate. Okay, so this is my equation here, and I'm going to just record that over into my notes. So I'm rounding to the nearest hundredth for A, so that will be 24,186.67, and the nearest thousandth for B. Okay, so it says explain how the value of B is related to the answer in the previous bullet. Okay, so this 0.965, it's a decreasing number because it's less than 1, which means this is how much I'm keeping from year to year. So my B value of 0.965 is how much I'm keeping from year to year. So to figure out how much I'm decreasing from year to year, and if I were to subtract those, I would get 0.035, which is the same amount here. So this is the keep amount, and 1 minus the keep amount is the decrease amount. So I know it's decreasing by 3.5%. Okay, on the next page to finish this question off. Okay, so to answer the remaining parts of this question, we have a neighboring town, so now this is a different town, has been experiencing a decrease in population since 2007. They have a new equation, and it can be used to estimate the population of the town n years from January 2007. By what percentage is the town decreasing? So I'm going to use that same idea. This is the keep amount. So to figure out the decrease amount, I just go 1 minus 0.93 is 0.07. So it is decreasing by 7% every year. So use the equation from above to estimate the population of the town to the nearest hundredth in January 2017. So January 2017, well, 2017, take away where I started, is 10 years later. And 10 years is an X value. So what I can do is just plug X into the actual equation to figure out what the Y value is. And that's what I would do if there wasn't a second part. Because there's a second part, I'm going to use my calculator to help me. So this is an example of X given, which is 10, and Y needed. So I'm going to use trace. Determine which year the population of the town first would be expected to fall below 6,000. So 6,000 is your population. So this is an example of Y given, which is your population, and X needed. So in that case, I'm going to use Y1, Y2 intersect. And I don't need that many E's in needed. I guess I really needed it. Okay. So let's go into our calculator, and we're going to change our equation turn off my plots. There we are. And enter in our new equation. Okay, so our new equation is 18,400 multiplied by 0.93 to the exponent of x. Okay, let's see what the graph looks like if my windows are okay. Well, let's see. We'll go with this window setting, see what we get. So in the first question, or the first bullet, it was saying x is given as 10, and I want to know what y is. So I'm going to go trace 10, press enter. Okay, this is good that you guys are seeing this. This means that I don't have a big enough window setting to see it. So let's go into my window setting and see I'm only going up to 5.5. So I need to adjust my windows. So let's say 15. Oops, 15. And then we'll go up by, say, 1s. Now let's just look at my y values. Yeah, that should be good for my y values. Okay, so now let's go into the graph. There we go. Better. And now let's try trace 10. So if you guys ever get an error question like that, it's just that you have to adjust your windows. Okay, so there is my population, and they want us to do to the nearest 100, which would be 8,900. So we'll write that down over here. So this would be 8,900. And then determine in which year the population would be expected to fall below 6,000. 6,000 again was a y value, so I'll put that into y2. And then graph, and I'll find the intersection point right there. That should be big enough to calculate it. Let's give it a try. If it's not, we can adjust our windows. So second calc, option 5 for intersect, and press enter 3 times. What are we doing? It's thinking about it. Okay, so my calculator's not cooperating with me. So let's make this a little bit bigger. Our y value, let's make it like, I don't know, we'll go up to 30,000. Really exaggerate it up by 1,000. Okay, let's see if this will be enough. Okay, I just want to make sure everything is good to go. 18,000, yeah, that looks good. Okay, let's see if we're going to be able to do it. Second trace, option 5 for intersect. Enter, enter, enter. Is it going to work with me? It's thinking too long. Yeah, I'm going to have to adjust my windows again. Oh my goodness. Okay, let's try this again. Let's make our windows a little bit bigger. I'll go up by 2s. Okay, now let's see. We're going to graph this a little faster. Okay. There we go. Okay, so here we go. Moral of the story. You need to clearly and obviously see the point of intersection. So second trace, option number 5. Enter, enter, enter. Work with me, calculator. There we go. Oh my goodness. My calculator was not my friend today in this lesson. Okay, so it's going to be 15.4. So it's going to be 2007 plus 15 and partway through, right? So it's 15 and a bit. So it's going to be during which year, determine in which year. It's going to be partway through 2022, and that would be your final answer. Okay, so I hope this helped and you guys see some common calculator errors that you yourself could get, and this will help prepare you for your Chapter 4 test assignment. We'll see you in the next video.